Okay, so what we're going to do today is go over chain rule. Chain rule is just another rule like product rule, quotient rule, power rule that allows us to find the derivative. So looking at these over here without the chain rule, do you know how to take the derivative of x squared plus 1?
Yeah.
Yes. Yeah, what is it?
2x.
2x, okay. What's the derivative of the second one?
Cosine.
Cosine x. The next one?
3.
3. The last one? 1 plus squared x. Okay, so all of these we already know how to do. All right, these over here, we don't know how to take the derivative of this yet. All right, we don't have enough. You can't use power rule on something like square root of x squared plus 1. Square root of x, we were okay with, but not square root of a function. All of these are what we call composite functions. They're all a function of another function. So basically, there's two main things going on each of these. Like on the first one, we have a square root. That's one big thing. And on the other one, we have this x squared plus 1 that's polynomial. Look at where the 6 is on the next line. We haven't done this yet. We have done it where the 6 is in front. Okay, we know how to take the derivative of 6 sine x, but not sine of 6x. Okay, the third one, we actually could do this one using the product rule. How do you think we would need to do that?
Simplify what's is.
Okay. So this is 3x plus 2 times 3x plus 2 times 3x plus 2 times 3x plus 2 times 3x plus 2. That's a lot of product rule. So we really don't want to do it using the product rule. I don't even want to multiply that out and use the power rule. We also haven't done it where we are taking tangent of something like x squared. All right, so what this is going to do is it's really going to open us up to being able to do a lot of new types of problems. Okay, so I'm going to explain this, and I'm going to use the M&Ms kind of as a way to help. So I'm going to start with a green M&M, all right? Okay, so go ahead and open up your M&Ms. Don't eat them yet. You just put them on your paper. And I'm going to start with the green one. If you have a green one, you can start there. But if you don't, it's okay. It doesn't really matter which color you start with. But I'm going to color code my notes to fit with a green M&M. Okay. So M&Ms basically have two parts. What are the two parts?
The shell,
the shell and the chocolate. The shell is what we would call the outside, and the chocolate is what we're going to call the inside. Well, when you're doing f of g of x, the f is what we're going to call the outer part. Okay? And the g of x is what we're going to call, I'm going to use this other color here, the inside part. Okay? And this is really a purple color, but it's pretty close to brown, so that's why I'm going to use that. All right. So looking at this first example, what would you say is the outside function? Something that's happening to the entire thing. Square root. Okay, that's the same as saying something to the 1/2 power. All right, now, what's the inside function? Yeah, it's what's underneath the square root. The x cubed plus 2. Okay, so we're about to eat this M&M, and when we eat the M&M, when something melts, we're taking the derivative. So think of melting is the same as derivatizing, which is a word I just made up. It just means taking the derivative. Differentiating would be the technical term. But derivatizing just has a nice charm to it. So what would we do if we had like x to the 1/2 power and I was taking the derivative of it? What would that become? 1/2 and then x, so I'm not going to put x, I'm just going to put something. And then what would be the new power? -1/2. Okay? And I'm leaving this part blank for a particular reason. All right, what would be the derivative of g prime, or what would g prime of x be? 3x squared. Okay, so what we're going to do now is I'm going to show you how to write your final answer. Okay, those are all the pieces. So I'm going to take my M&M, and you cannot chew it. Okay, you'll get to chew your M&Ms later. But for this first one, I just want you to put it in your mouth. Don't chew it.
The green one?
The green one. Green color. You can suck on it. So tell me, what's melting right now?
The shell.
The shell and only the shell. The chocolate remains unchanged, so watch what I'm going to do. Remember the outside shell melting? That's 1/2, parentheses to the negative 1/2. And the chocolate on the inside, x cubed plus 2, has not changed. It's the same. Right now. We're not done. We're not done with our M&M either. But right now, the only thing that changed was the outside shell. Okay? Chocolate's the same. Like at this point, though, are you tasting chocolate?
Yeah.
It's like almost impossible not to chew it, right? So we're tasting the chocolate. So this is the inside function being taken the derivative of, okay? So remember that was 3x squared. We're going to multiply by 3x squared. So I'm going to repeat how we did this mathematically and how we did it with the M&M, and we're going to do another one. So first we just identified the outside function. That's what's happening to the whole thing. That was to the 1/2 power, the square root. And then the inside function. And we took the derivatives of the two pieces. Your final answer is going to be the derivative of the outside, keeping the inside the same, then times the derivative of the inside. That's what this formula right here means. Some of you are going to stick to the formula. Some of you are going to really use this M&M thing, and we're going to explore this a little bit more. And some of you are just going to come up with some other way to remember it. Okay? So let's look at the next problem. What would you say is the outside function of cosine of 6x? Cosine. So I'm going to say cosine of something. Okay, because in this case it's 6x. Normally it would be of x. We're just going to leave that part blank. Then the inside part would be the 6x. Okay. Now, you should be really good at filling in the next two blanks because we're just taking the derivatives of the two pieces. So derivative of cosine would be negative sine. Derivative of 6x, that would be 6. Okay, so now we get to the M&M. So I want you to do this with me. We're not going to do this on every column, but I want you to take an M&M. Some of you might be out because you're hungry. And I just want you to put it in your mouth. Don't chew it. I want you to let this sink in. Only the shell is melting. So we only take the derivative of the shell, which was negative sine x, in this case sine of something. The chocolate, however, remember what was the original chocolate 6x? That's not changing at first. So the shell changed, the chocolate remains the same. Okay, so you write that down. Then you gotta think, okay, depending on how acidic your saliva is, or how hard you're sucking on the M&M, eventually you're gonna taste the chocolate. So the chocolate's melting, it's changing. What's the derivative of the chocolate? Times 6. Okay. So I'm trying to reach all my different types of learners out here. All right? Any questions so far before we do another one? So I'm going to pick up the pace a little bit. Okay, so as we're doing this, feel free to eat your M&Ms. Think about the process. We're not going to do another one probably all together like this. Okay, so the third one, what is, mostly just because if I keep eating them, it's hard to talk. So what's the outside function? What's the outer function on this third problem here?
Power to the fourth.
To the power to the fourth. So I'm going to write parentheses to the fourth power. And then the inside function would be 5x plus 2. And now we're going to think, okay, if I take the derivative of the outside, the shell, that's going to be, I would just do 4. And then in my parentheses, and then a cubed. It's just like if it was x to the fourth, it's just something else to the fourth power. Taking derivative of the chocolate, of the inside part, that's just going to be 5. So go ahead and see if you can write the answer down on your own, the final answer over here. look up here, check your answer. Again, some of you, you're going to want to use the M&M analogy every time. You're going to want to think about the shell, chocolate's remaining the same, then the chocolate's melting. Some of you are going to be thinking about the derivative. Some of you are going to say, we do this, then we do that, but the next step is this. It just depends on how you think. I don't care how you do it, as long as you have a system that works for you. Okay, let's look at the next one. What's the outside function? Cotangent. Cotangent of something. Okay, the inside then would definitely be x squared. What's the derivative of cotangent?
Negative cosecant.
So the derivative of tangent, secant squared. So the derivative of cotangent is negative cosecant squared of something. And then the derivative of the chocolate is 2x. So then my final answer here should be the derivative of the shell, the outer part. Keep the chocolate the same. I keep the inside part the same, x squared. Then I multiply by the derivative of the inside part. This is chain rule. Yes, Nika.
I'm gonna drink water.
Sure. All right. This next one's not too bad. Go ahead and try to do this next one on your own. It's 2 trigs, but still, you can do it. When you're done, eating them in. Okay, what was your final answer on this one? Negative sign of sine x times cosine x. Do you think it's possible that someone might get confused on this one and think that they should do a different rule instead of chain rule? What rule do you think some people might look there and say to use? The product rule. It kind of looks like if you, I mean, we're doing chain rule, so we're like thinking chain rule, chain rule. But if this was mixed in, you might look at that and say, hey, that's cosine x times sine x. How do we know it's not?
There's no x for cosine.
There's no x for cosine, which tells us that we're actually taking cosine of sine. Okay, so these are the things you're going to have to look for in the future that could be kind of stumbling blocks. All right, what type of rule do you think most people would want to use on the next one? Quotient. And you know what? Doing quotient rule on this is how we would have done it before today. And that's a totally legit way of doing this problem. I'm going to stretch you just a little bit, and we're going to do this with the chain rule. So think of it this way. This is the same as 1 over a function, or a function to the negative 1 power, right? And this works because I only have 1 in the numerator. If I had something other than 1, this problem would get a little bit more complicated. So that's the outside function. What would the inside function be? 2x plus 1. And then the derivative here would be negative 1, parentheses, negative 2. So my final answer, negative 1, parentheses, negative 2. We fill in the chocolate, don't change it yet, then times the derivative of the chocolate. Okay, let's see if we can do the next one without filling in all the steps. Because this is really where we need to get. We need to get to a place where you can do the chain rule and basically write down your answer. Okay? I'm going to go ahead and keep my color coding though. So when you're looking at this, and by the way, if you get confused right now, go ahead and fill in the steps. That's fine if you want to do that. When you're looking at this, you need to identify, okay, the outside is sine. Think about it like this. You're eating the M&M. The first thing that's going to melt is the sine. What is it going to become? Cosine. Cosine. What's not going to change is that 3x, at least right away. It's not going to change right now. Okay? But then after a while, it's going to melt, and you are going to take the derivative of the inside, which would be 3. Now, if you notice, a lot of times what we're multiplying by is a number. If you wanted to simplify this and put that number in front, you could, but you don't have to. It's just like all the other ones that we've done. Okay? How could I rewrite this square root problem so that I could do this in one step and it would be easier? Right. I'm gonna put parentheses around this and write it to the 1/2 power. So when I'm taking derivative of something to the 1/2 power, using the power rule, 1/2, I'm going to leave a big space here since it's something that's longer. The new power is going to be 1 less, and everything on the inside is remaining the same. It's not changing yet. That's a 1 right there. Then we multiply it. What's interesting about this problem is, this is the first time this has happened today. What we're multiplying by is more than just one term. All right, so what's the derivative of the chocolate? 9x squared minus 2. Because this is a whole term, we need to put that in its own parentheses. Otherwise, order of operations would say that we're really multiplying by the 9x squared and not the minus 2. So just be aware of that. When you melt that chocolate and you get something here, probably gonna need parentheses. Okay, I'm actually gonna go ahead and stop there on that one. I want you to turn the page. I'm even gonna skip over 1 and 2. And what we're gonna do is look at number 3. Okay. I am going to switch colors, and I'm not going to color code anymore. If you want to color code on your own paper, that's fine. Okay, so this is really the ultimate goal here is, can we solve a problem start to finish without all the leading steps? So the first thing we got to realize is, do we need to use chain rule? What do you think on number 3?
Yes.
Yes. Because I have a square root and I have a polynomial, but I am going to rewrite this so that it's to the 1/2 power. Okay, so the derivative of h, or h prime of x, I'm still going to think of it like the M&M. The only thing that's going to change it first is the outside. So what should I write first? 1/2. And then the inside part is staying the exact same. My power, I subtract 1. And I'm not done yet. That's just the shell melting. Now the chocolate's going to melt. What is that? 3, the derivative of the inside, which would be 3x squared. And that's your answer. So again, some of you are going to be you're really going to like this whole M&M thing. Some of you are going to be thinking formula. Some of you are going to be thinking you do this, you do that, and the last step is you do this. Everybody's different. You do what works for you. Because think of it this way. If my function was something like that, and I wanted to take the derivative of y, I would do 1/2 times 1 like the power rule. Then I would subtract 1. It's just like that, except instead of x, we have a whole other function in its place. And if we did do chain rule on this, by the way, if I was using chain rule and the inside was just an x, what's the derivative of just x? 1. So chain rule works even if you did it on a problem that didn't need it. You would still work. It wouldn't cause you to get the wrong answer, but you obviously wouldn't need the plus 1. Okay, so what I would like for you guys to do is go ahead and do 4, 5, and 6. And if you want to go ahead and go to the back, if you're already, some of you are already done with those and you want to go to the back, I want you to do these. Ask me questions. Ask your partners that are sitting next to you questions. We'll go over it. Okay, it looks like everybody's done with at least 4 and 5. So what did you guys get for h prime of x?
4.
For number 4, what did you get?
Negative sign. 6.
Negative sign of 6x times 6. Okay, good. What about number 5?
4 times the quantity of 5x plus 2 cubed
Good.
times 5.
Times 5. And 6 could trick you if you weren't careful on this one. You should have gotten h prime of x equals negative cotangent x squared cosecant x squared times 2x. I barely get that squeezed in here. You do need the x squared here and here. The reason is because the derivative of cosecant's negative cotangent, derivative of cosecant of x is negative cotangent x, cosecant x. Here, the inside part was x squared. You need it in both places. All right, let's go ahead and look on the back. Some of you are already there. Again, I want you to notice that with 7, it seems like if you're not careful, you think you need product rule here, but you don't. This is not the same as cosine of x times sine of x. This is a function of another function. Okay, I want you to go ahead and do 7 and 8. And don't get too freaked out by this. This is just another way to think of it, like another way to do the formula. We're not going to talk too much about this today. Okay, it looks like you are on the bottom part. Let's go ahead and go through over 7 and 8, and then I'll let everybody work at their own pace for the rest of it. So what'd you get for number 7?
Negative sign of sine x.
Negative sign of sine x times cosine x. Good. And then number 8, we could have used quotient rule, but we really would need to practice this new chain rule. And so hopefully you did something like this, maybe as prep work, or at least you thought of that in your mind. And so for number 8, what then would be the derivative? Negative 1, 2x plus 1, times 2. And which do you think is easier on a problem like number 8? The quotient rule or this chain rule? Probably this, which at least if you're comfortable with it. Quotient rule had more parts, and this already gives you a simplified answer. Do you remember how in the quotient rule, how you would have over denominator squared? That's what this part right here is doing. It's the denominator to the negative 2, that's just squared in the denominator. So it's not different, it just looks different because it's a different form.